Hello, welcome to this video on the boot process in Oracle Linux. This video describes the high-level steps of the boot process in basic input-output system or BIOS mode. We describe the high-level steps of the BIOS firmware bootloader process. Understanding the Linux boot process is helpful when attempting to troubleshoot boot problems. You need to be aware of the files involved in the boot process because errors in these files can cause boot problems. After powering on your computer, the BIOS firmware performs power on self-test, or post. The BIOS then reads the master boot record, or MBR, for the bootloader. On a computer with x86 architecture, the master boot record is the first 512 bytes of the boot partition that is read into memory by the BIOS. The first 446 bytes of that 512 bytes contain low-level boot code. For some bootloaders, the code in the MBR points to further bootloader code somewhere else on the disk or on another disk. The next 64 bytes contains the partition table for the disk. The last 2 bytes are the boot signature, which is used for error detection. The bootloader software runs when a computer starts. It is responsible for loading and transferring control to the kernel. The kernel then initializes the rest of the operating system. Many bootloaders are available. The most common bootloaders for Linux are Lilo, L-I-L-O, which stands for Linux Loader, and Grub, or the Grand Unified Bootloader. The default bootloader used in Oracle Linux is Grub 2. Continuing on with the high-level steps in the BIOS firmware bootloader process, the Grub 2 bootloader loads the vmlinux kernel image file into memory and extracts the contents of the Initramfs image file into a temporary memory-based file system, tempfs. The kernel mounts this Initramfs as part of a two-stage boot process. The Initramfs is an initial root file system that is mounted before the real root file system. The job of the initial RAM file system is to preload the block device modules, such as for IDE, SCSI, or RAID, so that the root file system on which these modules normally reside can then be accessed and mounted. The Initramfs is bound to the vmlinux kernel image. For example, if the kernel version is 5.4.17, there is a vmlinux file and an Initramfs file containing the same version number. Both the vmlinux kernel image file and the initial RAM disk file are located in the /boot directory. To show the locations of the vmlinux kernel image file and the initial RAM disk Initramfs file, I'll begin by viewing the partition table for the devices on my system. Notice the primary boot disk for this system is /dev/sda, which has two partitions, sda1 and sda2. /dev/sda1 is the boot partition and is designated by the column with the asterisk. I can then show that /dev/sda1 is mounted on /boot. Finally, if I list the contents of the /boot directory, I see Initramfs and vmlinux entries. This shows that 3 kernels have been installed: the Oracle Unbreakable Enterprise kernel, or the UEK, the Red Hat compatible kernel, and the rescue kernel. The rescue kernel boots a Red Hat compatible kernel with a known good Initramfs. If your system does not boot with the desired kernel, you can boot the rescue kernel and correct the problem. Another use case for the rescue kernel is booting the system with different hardware, such as when the disk is being accessed remotely or has been physically removed between systems. After the newly loaded kernel gets far enough along in its initialization sequence, disk are probed, memory is mapped, and so on, it then switches over to using the real root file system as specified by the root directive in the grub2 configuration. This grub2 configuration file contains, among other things, the /etc/fstab file, identifying the rest of the file systems to be mounted. The kernel then starts the systemd process, which has a PID of 1. Systemd is the ancestor of all processes on a system. Systemd reads its configuration files, which controls how it handles system initialization. Systemd brings the system to the state defined by the system target, performing system initialization tasks such as setting the host name, initializing the network, initializing SE Linux based upon its configuration, initializing the system hardware based on kernel boot arguments, mounting the file systems, including the virtual file systems such as the /proc file system, cleaning up directories in /var, starting swapping, and many other things. This concludes this presentation. Thank you for watching.